So for skill 10, we picked 4 numbers. The first two were integers, 12 and 15. The second two were pi over 6, and then 2 pi over 3, because those will form special right triangles like we were asked to find. And then we drew those out over here, and this is what we got in the root pi over 3. Use the unit circle, we know that these points are equal to these values. Also for this, the unit circle can be used to do that. And then, so for this one, we know that we are finding the basic vector, and we're putting these into the right notation. So what we did was we put 15 cosine root pi, or cosine 2 pi over 3, and that just becomes negative 1 over 2, because cosine of this angle would be adjacent, which is this, over hypotenuse, which is 1, so that's what that would become. And for this one, we would do 15 sine 2 pi over 3, so we would go sine is opposite over hypotenuse, so it's opposite over 1, so root 3 over 2 over 1, so that's what we get from here. And once we plug that in, we get negative 15 over 2, and then 15 root 3 over 2, or also 7.5 and 15 root 3 over 2. For this one, we do the same thing. We do have the cosine. You have to end up multiplying by 12 because of this value. And same thing for the 15 and that value, because this unit circle is for when these values are 1. But right now they're bigger, so we have to multiply the whole thing by them after. So we know that cosine of pi over 6 is root 3 over 2, because cosine is adjacent over hypotenuse, so root pi over 3 over root 3 over 2 over 1, or just root 3 over 2, and then sine of the thing would be opposite over hypotenuse, so 1 over 2 over 1, and then multiply it by 12 to get 6 root 3 and 6, which is rounded 10.39 and 6. Then we were told to find the magnitude and direction of the added values. So to add them, we just put them next to each other. This is our first vector, and this is our second vector. These values, this value is from our first vector, and this is also from our first vector, and this one's from our second, and this one's from our second. So after we do that, we get 2.89 for the x's, and then 18.99 for the y's, and so we know that to find the magnitude, we got to do so these values squared and these values squared, square root the whole thing, which gives us 19.21, and then 19.21 for the magnitude. Let's write that over here. And then for direction, we already have the ratio, so we would just try tan of theta, because we're looking for the angle, is 2.89 over 18.99, which we get from these two values. And then so we have to find the inverse, so what we get over here is 8.65 degrees for our direction. And then to subtract, we would do the same thing. Get this vector from our original vector, and this is also the same vector, and then just add the negative value. So what I'm doing basically there is I had a negative value times that, and I distributed the negative to make each one of those negative. Once you add those up, you get about negative 17.89 and 6.99. So when you put those into the same equation to find the magnitude, you get 19.21. And then for direction, we would do the same ratio, and then 6.99 over 17.89, and then we would get about 21.355. But since we know that this value is negative, the angle is in the second quadrant, so we would have to shift it by making it 180 minus 21.355, which will give us 158.65. For the last part of the skill, we had to just multiply these together, and so for that it's real simple. These are the x values right here, these are the y values right here. So when you multiply those two together, you get negative 45 root 3, and then you get 6 times this is is 45 root 3. So when you add all of this together, you just get 0. So the dot product would be 0.